this slide appears in all of the type 1, type 2, type 3. A strong odor is an indicator of compressor burnout. If you think that your compressor has burned out, flush the system and watch for signs of contamination in oil. If nitrogen is used to flush the debris out of the system, nitrogen can be vented to the atmosphere. A suction line filter dryer should also be installed to trap any debris following the repair with the new compressor. You'll find this question in all the sections, 1, 2, and 3. Recovery speed. Long hoses will reduce pressure, resulting in increased recovery time. Since all refrigerants have a pressure-temperature relationship, the two things that are going to impact recovery speed is going to be if it's cold outside, that means lower ambient temperatures, and if you use long hoses. Those will cause your time it takes to remove the recovered refrigerant to take it longer. Dehydration is what we refer to when we use a vacuum pump. It is to remove water and water vapor from a refrigeration system. If moisture stays in the system, let's say it's an R22 split air conditioner, they were called wet systems. They liked water. If you have water that stays in it, water vapor, in the compressor they'll form hydrochloric and hydrofluoric acids. And the way to get rid of this is to use a vacuum pump, evacuate the system, and then we will be able to remove the moisture. One thing to keep in mind that they want to emphasize is that you can never overdo it with the vacuum pump. You can't damage a system by keeping it in a low vacuum for a long period of time. Never evacuate a system to air without first following the proper recovery procedures and attaining the mandated vacuum levels. Here refers to that recovery efficiency chart that you're going to see. So, evacuation essentials, in other words, vacuuming essentials for accurate reading and speeds. What should they be? The vacuum line should be equal to or larger than the pump intake connections. That's your 5/8, your 1/4 inch connections. The piping connections to the pump should be short as possible and large in diameter as possible. The system vacuum gauge should be connected as far away as possible from the vacuum pump. What affects the speed and efficiency of doing a vacuum? Well, the first is the size of the appliance that you're working on. If it's a 50 pounds of refrigerant system, is going to take quite a little longer than it would if it's a refrigerator. What is the outside air temperature? It's another factor that's either going to increase the speed or decrease the speed. The other is, if it's a R22 system and it really likes water, it has a lot of moisture in the system, and you can see that the moisture indicator on the sight glass where the filter dryer is pink. Then you know, well, we've got a lot of water now we've got to get rid of. And the last is the size of the vacuum pump that you're using, whether you bought it from Harbor Freight as opposed to Yellow Jacket, is going to decide how long it's going to take to get it to the proper level. Some precautions. If you use a really big vacuum pump, it could cause trapped water to freeze. During evacuation of systems with large amounts of water, it may be necessary to increase pressure by introducing nitrogen from time to time to counteract the freezing. Completing the vacuum process or completing the dehydration removal of the moisture. Measuring a system's vacuum should be done with the system isolated, meaning the manifold gauges are gauged off, and the vacuum pump turned off. A system that does not hold its vacuum level and goes back up to atmospheric pressure is going to be because it has a leak. The dehydration's finished when the vacuum pump with vacuum gauge shows that you have reached and held the required finished vacuum, and the next slide should be that number. It is. When do you know? It is difficult to determine dehydration effectiveness when you're using just your compound gauge that reads in inches of mercury. That's why they recommend that you use a micron gauge. And the number that you're looking for on your micron gauge is 500 microns of vacuum to assure proper dehydration. So 500 is the number you want to remember, 500 microns. This is the chart I was talking about. This chart here is really great. It's in your handout, and it's something, take it and consider, because picture's worth 1,000 words. Microns, inches of mercury. Now we have temperatures. This is the temperature that water will boil. The temperature water will boil. What we do is we start at the bottom. Water, when we're at sea level, boils at 14.7 pounds per square inch and will boil at 212 degrees Fahrenheit. So, when we're showing 0 inches of mercury, then that means water is going to boil off at 212 degrees. That's 0 mercury. That's the equivalent of 760,000 microns. And if it was at 14.7, if we had PSI, it would be right here, 14.7. As we go up, we're going to increase the vacuum. This is going to be at sea level. Everything from here is now what they say when they talk about a partial vacuum. So, 25, let's say that we get to the number that they recommend, 500 microns for the vacuum gauge, is the equivalent of 29.90 inches of mercury. Water boils at -12 degrees Fahrenheit. So that's why when we put our vacuum gauge on, vacuum pump on, we bring the vacuum down to 500 microns, or on our gauge set it would look like it would be 30 inches of mercury. We're boiling water inside that tubing at -12 degrees Fahrenheit. So we started boiling water much sooner. When did we start boiling water? Typically, let's say that the ambient temperature where the machine is, let's say it's 70 degrees. So from here to here, we were boiling water all the time. From 20,000 microns all the way to 500. As we were pulling that pump down. That's why when you turn on the vacuum pump, one of the first things you start to see really quick around here, because we're using very small systems, is you start seeing steam come out of the vacuum. That's because it's boiling already. So recovery cylinders. A recovery cylinder are those cylinders that we replaced a few months ago. They have gray sides, they have a yellow top, they have 2 ports on them, one for liquid, one for vapor, and we can use them to recover refrigerant and store refrigerant as an external container. Some things to be reminded about. 1, never heat a refrigerant cylinder with an open flame. The EPA requires that refillable cylinders must not be filled above 80%. So the key word here is the 80%. That's what they're looking for. If you see refillable cylinder, recovery cylinder, how much to put in there, it's never to exceed 80%. And the 80% is the answer on the test that you're going to look for. What we use here for how to determine the 80% is going to be float device, electronic shut-off device, or weight. we've been using the scales, so we're using weight. So what you do is you look at the recovery tank itself, and you'll see stamped into the metal are two numbers. One is going to be the TW weight, the other is the WC weight. The TW weight is the weight of the can itself. It's made of steel, this is what it weighs. The WC weight is the water weight. You take those two numbers, you add them together, and you get a total weight. The 80% is the 80% of that total weight of those two cans. That's the number. So here's their picture of what a refillable cylinder looks like. Other thing about refillable cylinders, everything that you are studying and doing for this exam is under the EPA. The cylinders are not. The cylinders are going to be covered under the Department of Transportation, DOT, because the DOT has jurisdiction over anything that's compressed, any compressed containers that is transported over the road. It's under the jurisdiction of the federal DOT. So if they ask who's responsible for the regulation of refillable, pressurized refillable recovery tanks, it's not the EPA, it's DOT. So the first thing they require is that they are shown as yellow tops, gray bodies, and it's just like a propane tank. They should not have rust on the top of them, and they should not appear to be damaged. When they're transported, are to be transported in the upright position. They should be chained and labeled. The one tank we just talked about was the refillable tank. There's also disposable tanks. And those disposable tanks is where you buy the new refrigerant. They're a lighter weight tank, and they're going to be color coded, and they're going to say on the side of them what kind of refrigerant goes in them. They are, like I said, used with factory fresh refrigerant. They're never used for recovery. When you're working with type 1 equipment, it's going to be necessary that you're going to have to inspect Schrader valve cores, because this is going to be the main means of putting recovering refrigerant and adding refrigerant to a system, is these Schrader cores. Always cap a Schrader port to prevent accidental depression of the valve core and the leaking of refrigerant out of it. So when you go there and you work on the job, when you leave, by EPA rules, you have to make sure you put the screw cap back on. Also, personal safety gear. When handling, refilling, and filling refrigerant cylinders for operating recovery or recycling equipment, you should wear safety glasses and protective gloves. Nitrogen pressure testing safety. When you're using, when you're pressurizing a system with nitrogen, you should do the four things. Charge through a pressure regulator, insert a relief valve in a downstream line from the pressure regulator, never install relief valves in series, replace the relief valve if corrosion is found within the body of a relief valve, and to determine the pressure that you're going to charge the system with the dry nitrogen to check for a leak, you're going to never exceed the low pressure operation number. So if it says that it's a R22 system and it's for air conditioning with a 40-degree coil, then it's going to say on the data plate that the low side pressure is 69 pounds PSI. You're not going to go over for your pressure test 69 pounds PSI. Oxygen and compressed air. You can't get by and use pressurized air to leak check a system. You have to use dry nitrogen. When leak checking a system, never pressurize the system with oxygen or compressed air. When you do this, it may cause an explosion when they mix with the refrigerant and the oil under those conditions. Now, safety having to do with release of refrigerant. Refrigerant is, one of its qualities is that all refrigerants, I believe I'm right in saying this, all refrigerants are heavier than air. Because they're heavier than air, they're going to displace the air in a room. If you're in a mechanical room in a building or in a basement space, confined space of any kind, if there's a refrigerant leak, it's going to push the air out and you're not going to be able to breathe. So, they're saying that what you should have by law is that you should have a self-contained breathing apparatus. However, recognizing that there's not many self-contained breathing apparatuses around here, you are to immediately vacate the area that's confined and then to ventilate the area. Again, never use an open flame to heat refrigerants. If it is a refrigerant that is a CFC or an HCFC that contains chlorine, when you use an open flame or a hot metal surface to heat it up, what you're going to have is a very, very cool thing happen. If you ever used a halide torch, where you have the blue propane flame coming out, if it sniffs the chlorine, it goes from blue to a very, very cool green. And what it's doing is it's burning off the refrigerant, and the green that you're seeing is the conversion. When you burn that refrigerant, it forms hydrochloric and hydrofluoric acids, and the one that makes the green is this guy, the phosgene gas, which is another word for mustard gas. World War I, mustard gas, that's what it would make. Shipping and transportation. Almost all of our refrigerants are going to be 2.2 non-flammable gas. They will not support a flame. We can burn them, but the second we take the flame away, it stops burning. So before you can ship them, you need to have some paperwork. The cylinder needs to be labeled what is inside the cylinder. The cylinder should be transported in the upright position. The stem should be up. They need to have a DOT classification tag indicating that it's a non-flammable gas. And in New York State, it should also be chained. It needs to be chained. So a Type 1 technician is, Type 1 appliance is any appliance, like I said, that holds 5 pounds or less of refrigerant. Who can work on it is any tech who has Type 1 certification, or he has universal certification. Recovery equipment manufactured before November 15th, 93. Now we're going to get into this whole 80% and 90% rule that you have encountered before. So if the machine was made before 93, it must be capable of removing 80% of the refrigerant, whether or not the compressor operates, is working, or achieve a 4-inch vacuum under condition of another standard, ASHRAE 740. If it was made after November 93, two things. One, it has to be certified by the EPA approved testing lab. An example being, like I said, Underwriter's Lab. You'll see there, if you look at our yellow-black machines that we have recovery, they have a UL rating saying this as capable of recovering not 80 but 90% of the refrigerant if the compressor works, or 80% of the refrigerant if the compressor does not work, or achieve a 4-inch vacuum under the conditions of ASHRAE 740. And this is the ABC chart. So this chart's in your book as part of your handouts. A equals after November, B is before, and the C with the cross is the non-operating compressor. So if it was after November, it's 90, A equals 90 or 4 inches, B before equals 80 or 4 inches, C, no compressor, is 80 or 4 inches. So that's their shorthand for how to remember that particular rule. Recovery equipment, in your manifold gauge hoses are required to have low loss fittings. The low loss fitting is either manual type, where it has a little cock gauge to close it, or it's going to be the ball type that has the automatic shutoff. That's the one that came with your toolkit that you purchased when you were here. The one that would go on to the high pressure hose with that little ball check is a low loss fitting. Leak repair requirements. We're talking about type 1 equipment now, 5 pounds or less appliance. There is no rule from the EPA that says you have to make a repair to this equipment. No rule, no requirement. What they will say is that you should, whenever possible, repair leaks or prevent leaks to help the environment, but there's not a legal requirement for that. Now, more about self-recovery techniques, and now we're going to go self-contained active. So let's read. Now this has to do only with type 1 equipment. You're only going to find this kind of stuff for the type 1. So, active recovery equipment stores refrigerant in a pressurized recovery tank. Before operating a self-contained recovery machine, open the tank inlet valve, remove excessive non-condensable airs from the recovery tank. An accurate pressure reading of refrigerant inside a recovery cylinder is required to see if it has non-condensables. The only way to figure this out is to take the temperature and pressure of the refrigerant in the cylinder to see if it matches what the right number is. So if you got R22 in a recovery tank, and the R22 is, what temperature? Let's say it's 40 degrees, we'll make it easy. 40 degrees, then, it's 40 degrees, then the pressure of that cylinder should be 69 pounds. If you're getting different, then it means that it has too much air that's gotten into that system. Now, remember before we had system dependent, passive. System dependent recovery process for small appliances captures, this is the one that's unique, refrigerant into a non-pressurized container. These are special charcoal activated plastic bag containers. Now, system dependent equipment captures refrigerant with the assistance of the appliance's compressor or an external heat source or a vacuum pump. A standard vacuum pump can only be used as a recovery device in combination with a non-pressurized container. This would be the only place where you hear them talk about using a vacuum pump to assist with recovery of refrigerant. A standard vacuum pump is designed for dehydration, primarily not for this, but this is the exception to the rule. It's type 1 appliance, and if you see where they're talking about a non-pressurized container, then it is allowed to use the vacuum pump to assist. The exception to the rule. When you use a system-dependent recovery process on an appliance that has a compressor that works, run the compressor and recover from the high side of the system. Usually one access fitting on the high side will be enough to reach the required recovery rate. That's at 4 inches of vacuum. As the as the appliance compressor should be capable of pushing the refrigerant to the high side. However, if you have a type 1 appliance that has less than 5 pounds of refrigerant with a non-working, non-operating compressor, you will have to access both the low and the high side of the system. And you're going to access this with piercing valves. That's what you're going to use to access it. It would be necessary to take measures to help release trapped refrigerant from the compressor oil. In order to do that, because there's going to be a little bit of oil, refrigerant that's going to stay in the oil, you're going to have to heat and tap the compressor to get the oil up. Because appliances with non-operating compressors cannot always achieve the desired evacuation rates, utilizing a system-dependent recovery equipment, the EPA requires the tech to have at least one self-contained recovery device, in other words, a recovery machine with its own compressor, available at the shop to recover refrigerant from systems with non-operating compressors. And if you have more than 15 pounds of refrigerant, you're going to be following another set of rules. Now, this is the piercing valves. This is how you're going to get into to remove this refrigerant that's in the small equipment. It's through the piercing valves. Piercing valves. Fittings should be leak tested before proceeding with recovery. It is generally recommended that solderless piercing valves only be used on two kinds of material, copper and aluminum. These fittings will leak, and they cannot be left on there as permanent ports for removing and charging refrigerant. So what you're going to do is, once you recover the refrigerant, you're going to cut these, take these valves off. They're going to have two holes in the suction line, a hole in the liquid line. You're going to split the pipe, and you're going to put a Schrader in there in its place. If you're lucky enough and you have a defrost heater around the belly of your compressor, if the appliance is equipped with a defrost heater, such as in a domestic frost-free refrigerator, turn on the defrost heater to help vaporize any trapped liquid refrigerant, and that will help you speed the recovery process. Now, this is actually a test question I've seen. Refrigerators built before 1950, good luck finding one, may have used methylformate, methyl chloride, or sulfur dioxide as its refrigerant, and should not be recovered with your recovery device. Small appliances used in campers or other recreational vehicles may use refrigerants such as ammonia, hydrogen, and water. Therefore, should not be recovered using current recovery equipment. So, your recovery machine, a black and yellow machine, it's made to remove three kinds of refrigerants: Class 1, Class 2, and HFC refrigerants. It's not designed to remove any of those things in the first part of the paragraph, nor is it designed to use recreational vehicle. Ammonia, hydrogen, and water are the components necessary for chemical absorption, air conditioning, or refrigeration. So no, we're not doing that either. So we're only going to use our recovery machines for CFCs, HCFCs, and HFCs. Another one, going back, charging cylinder. There's one in the electric lab, believe it or not. I haven't used one in 30 years, but here we go. When filling a graduated charging cylinder with a regulated refrigerants, Class 1, Class 2, CFC, HCFC, the refrigerant vapor that is vented off the top of the cylinder there must be recovered. Like I say, these things are, they've been gone by the way of the buffalo since the scale came out, weight scale. Type 2, technicians maintaining, servicing, repairing appliances that are considered high pressure or very high pressure, that have more than 5 pounds of refrigerant. You have to be a type 2 tech or hold universal. Examples, split air conditioning systems and heat pumps. Leak detection. After installation of a system, you will pressurize the system with dry nitrogen and leak check. And in order to determine the general area of a leak, use an electronic or ultrasonic leak detector. To pinpoint the exact location of that leak, use soap bubbles. A refrigeration unit using an open compressor that has not been in use in several months is likely to leak from the shaft seal. So if you see railroad cars have an electric motor, they have a mechanical coupling to go to a compressor. The compressor is usually 4 pistons, and these are 12-ton units that would hold more than 50 pounds of refrigerant. In the wintertime, they're not going to be running because there's not going to be a call for refrigeration. There's going to be a call for air conditioning. So what you have because you have not a hermetic compressor, you have an open compressor, and the compressor connects to a motor. It has a shaft seal. We have to create a barrier so the refrigerant doesn't escape through that shaft seal. So what we have is we use a carbon ring that constantly is pressed with a spring up against the faceplate of the end bell. Over time, when that compressor is not running, refrigerant will work its way behind that carbon ring and it will leak out. Those shaft seals, those carbon shields, also will wear out if they're being run excessively, and it's a source of a leak. If you have this leak, if you have a shaft seal, if you have an open compressor, then you can most likely consider that you're going to have to do a seal job in order to get this thing closed. Now, there was no leak requirement under the law for type 1 appliances, but that's not the case for type 2 and will not be the case for type 3. Here comes the law. The law is the same for type 2 and type 3. So if you learn the law for type 2, it's the same for type 3. There's going to be 2 parts. The EPA requires that if it's a comfort system, cooling appliance, meaning an air conditioner, that holds more than 50 pounds of refrigerant, it must be repaired when the annual leak rate is more than 15%. That's the first part of the law. So, if you have a system that has less than 50 pounds, the law doesn't apply. If you have a system that has more than 50 pounds, the law will apply. If it's at a house air conditioner system, it can't leak more than 50 pounds a year. So it can't lose more than 7.5 pounds. The next one has to do with commercial. Leak requirements, commercial and an industrial. The EPA requires that if you have a commercial industrial system, more than 50 pounds, the leak rate is a little more forgiving. It goes up to 35%. So for air conditioning, it's 15%. For commercial, it's 35%. In both cases, there has to be more than 50 pounds of refrigerant. Now, this is the definition of commercial and industrial. You know, it's pretty straightforward. Commercial is retail, food, cold storage sections, restaurants, supermarkets. Industrial is more like pharmaceutical, manufacturing, These are, the key here is customized appliances used in the process of making something, which includes ice machines and commercial ice rinks. And like I said, that's true for type 2. The same exact rules are true of type 3. Now, recovery equipment. Recovery equipment has to be certified by EPA using underwriters or someone else to meet the ASHRAE standard. Recovery requirements. Because refrigerants that you are recovering can contain acids, moisture, oil, frequently check and change both the oil and filter on a recycling machine. Recycling and recovery equipment using hermetic compressors have the potential to overheat when drawing a deep vacuum, because a hermetic compressor, as you know, uses the low pressure suction refrigerant to cool the windings of its motor. So before you use a recovery unit, you should also check to make sure the service valve positions, the recovery unit oil level, and evacuate and recover any remaining refrigerant in the unit's receiver. When you're working with multiple refrigerants, this last part is what I want you to really kind of like highlight or pay attention to in your tape. Because this is a test question. When working with multiple refrigerants, before recovering and or recycling a different refrigerant, purge the recover, recycle equipment by recovering as much of the first refrigerant as possible, change the filter, and evacuate. This is the first part of the question. This is the answer right in here. The only exception to the rule is the tech working with R134A, who has to use a special set of hoses, gauges for recovery. Recovering refrigerant in the vapor phase minimize the loss of oil. Recovering as much as possible in the liquid phase makes it go faster. The tech makes use to speed up the recovery process by packing the recovery cylinder in ice and or applying heat to the appliance. After recovering liquid refrigerant, the last step always is to recover as a vapor in order to get all of the refrigerant out. Always recover. The last step of recovery is to recover as a vapor. Refrigerant should be placed in receiver of units that have a receiver storage tank. Refrigerant, this is going to be, these two are two test questions right here. This has to do with gravity when they ask you this. Refrigerant should be removed from the condenser outlet if the condenser is below the receiver. Next one. In a building that has an air-cooled condenser on the roof and evaporator on the first floor, recovery should begin from the liquid line entering, the word down there is the evaporator. So it's going to be whichever one's the lower one that you're going to see. This is when you recover the refrigerant and you're replaced. Let's say we have a type 2 outside coil. It was shot. We recovered the remaining refrigerant into our recovery tank. We replaced with a dry coil. We can use the old refrigerant for that customer back into that new machine. We can't sell it to another customer. That's what that means. Now, this chart right here, this one right here, what you're going to do is that you're going to go over this chart so that you have it. They're going to ask you 5 questions minimum on type 2, and they're going to ask you about 2 to 3 questions in the type 3, and you're going to need to be able to read this chart. So this is the recovery efficiency chart right here. So, I'll give you an example. It has R22 system that has less than 200 pounds, R22 system, more than 200 pounds. Then down here they have any other kind of high pressure refrigerant, less than 200 pounds, any other high pressure refrigerant, more than 200 pounds. These are going to be the ones they ask you about right in here. So here's where you need to know, okay, they're going to give you a refrigerant. Is it a high pressure or is it a low pressure? And that's why I said if the refrigerant ends in an even number, it's a high pressure, and if it ends in an odd number, it's low. So example, R12. R12 is a high pressure refrigerant. It's also a CFC refrigerant. It's a high pressure refrigerant. Let's say I have a unit that has R12 refrigerant, and it goes into a unit that holds 160 pounds of R12. If the machine was manufactured before 93, that's a bad example because it's 0 and 0. R12, and it holds more than 200 pounds. Let's say this R12 unit holds 250 pounds. So I look here, I know it's a high pressure refrigerant. It holds more than 200 pounds, it's 250 pounds. If it was manufactured, the machine I'm using before 93, I have to get it down to 4 inches of vacuum. If it was manufactured with a newer machine that was manufactured in 2000, I have to bring it down to a 15-inch vacuum. That's my minimum federal required evacuation number, vacuuming number right there. Once you get to the desired level of evacuation of vacuum, you're going to valve off the system and you're going to see if pressure rises. It indicates that there's still refrigerant in liquid form or in the oil. Appliances can be evacuated to atmospheric pressure only if leaks, because it has too many leaks, makes evacuation to the levels we talked about before impossible. If we have a hole in the system, we're not going to get it to 4 inches of vacuum, 10 inches of vacuum, or 15, because it's never going to go anywhere but to 0, because the atmosphere is coming in there. So if you can only get to 0, then that's fine. That's as far as you can go. If you're working with supermarket refrigeration where they have compressors that are in parallel, you have to isolate them or you're not going to get to the proper recovery. And if you're using, you can't use system-dependent recovery if you're using appliances that hold more than 15 pounds. So you just can't use the compressor of the system that you're working on if it holds 50 pounds. You have to use an external recovery machine that has its own compressor. Major repair. Major repair test question type 1, type 2, type 3. If you remove any of these components, the compressor, the condenser, the evaporator, or an auxiliary heat exchanger coil, those equal major repair. It's the same type 1, type 2, type 3. Same question. To determine the kind of refrigerant, I recommend reading the nameplate. Okay, that sounds pretty self-explanatory. Filter dryers, type 2 equipment, usually split air conditioners, heat pumps, usually R22, they love water. So just sort of like going back in the past, filter dryers remove moisture from the refrigerant in the system. There is a limit to their capacity. Some of them are equipped with moisture indicating sight glass. When the sight glass changes color, the system has excessive moisture and needs to be two things. It needs to be recover the refrigerant, vacuum the system, dehydrate the system, and any time that you open one of these systems, you should replace the filter dryer. A crankcase heater is often found in a larger split air conditioner and heat pump. A crankcase heater is used to prevent refrigerant from traveling to the oil and the compressor sump when the unit is turned off. Periods of low ambient temperature, or they mean when the thing's not running. Refrigerant, if you have excessive oil in the refrigerant, when the compressor does start up, it causes compressor foaming, which reduces its ability of the oil to lubricate, which is going to scramble your compressor. And again, it reminds us that a hermetic compressor, sealed dome compressors, are all cooled by using the suction line refrigerant vapor. So if an R22 system, 69 pound PSI, means that we're pulling in refrigerant into that canister. That's about 50 degrees with the superheat. Liquid charging. Liquid charging is common with large Type 2 equipment, and it tells us here there's a risk of freezing during liquid charging of a system that uses R12. Begin with vapor from a vacuum level to a pressure of approximately 33 pounds PSIG if you're using an R12 refrigerant. Then you can continue your charge as a liquid charge. The reason why we bring it up to 33 pounds is that's above freezing for systems that use R12. And the reason we're talking about liquid charging is that Type 2 equipment usually is the equipment that's going to have double-digit weight of refrigerant, and you want to charge as a liquid so you're not spending your life doing this. Another standard, this one's ASHRAE standard 15, and it's a mechanical room, and it requires that the owners of the building must put a sensor up there that will sound an alarm if the refrigerant goes up to, if the refrigerant escapes and leaks into the area, confined space. Chart, here we go. Got one for you here. A1 means no flame propagation and lower toxicity. So most of the refrigerants, and all the refrigerants except one that I've seen so far on this ESCO Institute test, will be A1. When they ask you about R123, it is the one refrigerant that is a B1. It means there's no flame with that refrigerant, however, it has some toxicity. The bottom line is R123 is the only one that shows up as being a B1 refrigerant. R123 also you'll see is the one that is the one low pressure refrigerant that they're going to test you on. And R123 is also going to be the example refrigerant for the vacuum for chiller systems. Taking us right to Type 3. Type 3, to work on a Type 3 appliance, which is low pressure appliance, you have to have either Type 3 certification and or universal. What is Type 3? It is a low pressure centrifugal chiller operating below atmospheric pressure, using probably a shale style water box, evaporators, and what happens is that we study here, and this test is about mechanical compression air conditioning, not chemical absorption air conditioning. A chiller is a mechanical compression air conditioning system. The only difference is there's a whole other set of pumps that's used. It has a primary refrigerant, which is going to be in our example R123, and it has a secondary refrigerant, being R719. R719 is a fancy way of saying water. It's water. What we're going to pump throughout the building in Manhattan, these big buildings, we don't pump refrigerant through there, we pump water. We pump treated water so we can lower the temperature. But so what we're going to do is we're going to use the air conditioning part of this chiller system to chill the water and to give off the heat that the water absorbs. But the refrigeration cycle is exactly the same as type 1, type 2. That's why type 3 is no big deal to take this part of the test. The only thing you got to know is about two things we're going to talk about that's different. One's going to be the purge system, and the other's going to be ruptured disc. How it works: cold water. Remember, water is our secondary refrigerant. Cold water within the tube system circulates throughout the area where the heat is to be absorbed. The water then absorbs that heat from the area, this room, where we want it, not want it, and it transfers the heat to the refrigerant in the shell evaporator. The refrigerant travels through a normal vapor compression circuit, releasing the heat through a condenser. The system is protected from overpressurization by a rupture disc located at the evaporator. A rupture disc differs from a relief valve in that it opens and it stays open. If you get a chance, go into YouTube and look up rupture disc, and you can watch them blow up. They're pretty cool. Most system rupture discs for air conditioning blow at 15 pounds PSIG. And if you think about it just for a minute, that actually means they blow at about 30 pounds. 15 PSIG at 14.7 is really closer to 30 pounds. Low pressure equipment using 123 especially operates below atmospheric pressure in a vacuum. So the suction side of a chiller using R123 is in inches of vacuum. The outside air pressure surrounding gaskets and fitting is greater than the internal pressure. Because chillers are operating in a vacuum, instead of we having a leak and stuff pushing out, and you can see the little soap bubbles bubble out, crap comes in, gets pulled in. Because the internal pressure is less than the external air pressure, leaks in gaskets or fitting will cause air and moisture to enter the system. For this reason, it's important to have a tight system, and it's going to be also important to have a purge system. Low pressure chillers are equipped with a method of eliminating air and other non-condensables that will leak into the system. That method is the purge unit. And this is the test question here. The purge unit is located at the condenser. So the purge unit is actually mounted to the top of a condenser. So now leak detection. Detecting a leak in a low pressure system is unlike that of a high pressure appliance. Refrigerant does not leak out of a charged low pressure chiller. Air and moisture leaks in. So the way that we check this is that if you have accessible, there's going to be a discharge tank with the purge. Most of these things are automatic purge units, so it's doing it for you. So when you see the tank of the gunk that's being discharged get to be too much, it tells you something. It tells you got a leak. So the system's internal pressure must be raised above ambient pressure before leak testing can be done. The best method, now here's the test question, of pressurizing the system is through the use of controlled hot water, raising the temperature of the circulating water within the tube. Heater blankets, hang on. Heater blankets may also be used to aid in raising the system pressure. When controlled hot water or heater blankets are not really usable, use nitrogen to increase pressure. When pressurizing the system, do not exceed 10 psig. Exceeding 10 psig can cause the ruptured disc to fail. Leak testing a water box is accomplished by removing the water and placing a leak detector probe through the drain valve. That one's definitely on the test, I just seen it the other day. To leak test a tube, use a hydrostatic tube test kit. I also mentioned that this sheet here is a little bit shorter, but this one gets to the point pretty good. How did I lose all these things? There was only 1, 2, 3 guys. Did just more people show up?
No. They grabbed them for other people.
Ah, okay, that's fine. I'm just wondering how come. The major repair is the same thing, same story. Leak repair requirements, here we are, if it's comfort air conditioning, 15 pounds. If it's industrial, 15% and 35%. And in both cases, it's over 50 pounds. The same exact law. Applied for 2, same law for 3. No change. Same definitions. Low pressure recovery equipment. A recovery unit's high pressure cutout is set for 10 psig when evacuating the refrigerant from our low pressure chiller, and a rupture disc on a low pressure recovery vessel relieves at 15 psig. Most low pressure recovery machines utilize a water cooled condenser that is connected to the municipal water supply. This whole thing, municipal water supply, believe it or not, is a test question. Why? I'll never know. Recovery techniques. Refrigerant recovery using R11 or R123 refrigerant systems begins with liquid removal followed by vapor. No matter what kind of refrigerant you're talking about, when you get a test question, it's always you finish as a vapor, no matter which way you go. Water must be flowing through the tubes while refrigerant is drained to prevent freezing. The recovery compressor and condenser should also be operating. Substantial vapor remains within the system even after all liquid is removed. Now this one I had to look up the first time I encountered it because I didn't have this presentation. This is a question you see on the back. An average 350-ton R11 chiller, R11, it's a low pressure chiller, low pressure refrigerant, after liquid recovery will still contain approximately 100 pounds of refrigerant in vapor form. So they're saying after you recover the liquid refrigerant from a 350-ton R11 chiller, that there's still 100 pounds of refrigerant that's in vapor form there. And I think, did you have Hunter for hydronics, or did he? I know he covered this one.
No.
No? Okay.
Well, I had him when he was leaving.
Oh, okay.
So he really didn't care too much.
Yeah.
He didn't get much into the hydronics.
Yeah, all right. In an R11 system, 10% of refrigerant can remain in the system in vapor form even after liquid recovery. Recovery tips. If a system is suspected of water tube leaks, the water sides of the system should be drained prior to recovering the refrigerant. When vacuum testing a system, if the absolute pressure rises above 1 millimeter mercury to any point above 2.5 millimeter mercury, the system should be checked for leaks. ASHRAE guideline 31996. This one I want to point out. The test question doesn't ask this. It says pressure rises from 1 millimeter to it's 1.5. They make you add this number, add 1.5 to 1 to get this number. So just be aware of that. System oil should be heated to 130 degrees prior to draining to ensure the release of refrigerant from the oil. Initial charging after you've made your repairs and you're ready to recharge the system must occur in a vapor phase until the system pressure has reached 16.9 inches of mercury vacuum. This ensures that water will not freeze and the refrigerant will not boil. R11 at 32 degrees Fahrenheit has a saturation pressure of 18.1 inches of mercury. So, if you're using R11 refrigerant, you're charging, you have to get the pressure up to, it sounds weird saying up to when we're talking about a vacuum, but up to 16.9 inches of mercury at vacuum. The system is charged for the lowest access point on the system, the evaporator charging valve. Another one, key one, remember that one, because it's definitely on the test. And these are kind of counter what you expect it to be. You don't really think of charging into the evaporator charging valve, you know. But you got to remember, we're charging as a vapor, and we're trying to get the refrigerant in the vapor state up to where it's not going to boil off the refrigerant. We want that to happen once it gets into the evaporator. Now, the chart I said, the 4 inches, 10 inches, 15 inches, those were all for R22 and other high pressure refrigerants. The other half of that chart, the bottom half, is actually this. It's the low pressure. Your book, Unit 9, they had that, they would show all both the high and the low. But here it is here. Levels of evacuation for low pressure appliances. For refrigerant recovery or recycling equipment before 1993, the number is 25 inches mercury. If the thing was made after 1993, it's 25 millimeters mercury. Keep that in mind. We got 25 mm, 25 Hg for the before and after. And that's why I say, if you can, try to cram that chart and write it out on a piece of paper. This way you have it. When I was at BOCES, what we had is we actually put up on the board a chart very similar to this one, and I'd have them practice drawing it out. Because it's not worth doing all the studying just to mess up on a few numbers. System pressure should be monitored after evacuation for a few minutes to ensure the maximum amount of refrigerant has been removed. If the pressure goes up, you got to continue the recovery. That's pretty straightforward. It means still refrigerant there. Systems that cannot attain or maintain level of evacuation should be evacuated to the highest possible level before the repair. Freezing water should be avoided. If necessary, use dry nitrogen to increase pressure to counteract freezing while vacuuming the system. Strong odors, again, compressor burnout. The purge unit, this one, the purge unit operates with suction from the top of the condenser. It removes air, moisture, and other non-condensables from the system and returns refrigerant, should be to the evaporator. If frequent purge operation occurs or excessive moisture is found in a purge unit, one of the system's tubes is most likely leaking. Ruptured disc releases when the pressure exceeds 15 psig, and they are there to keep the system from overpressurization. In this case, we have another standard, ASHRAE standard 15. Why, you may ask, is there another standard? The other one was for the refrigerant that displaced the oxygen because it's heavier. But remember, this refrigerant is going to use the B1, R123, is toxic. So we have a double hit here. because it's toxic, can't breathe it. So, we have ASHRAE standard 15. Monitored for high refrigerant levels in which an alarm must sound and a ventilation must be automatically activated. All refrigeration systems must be protected by a pressure relief valve. Here's the question, here's the answer. Never install relief valves in series. They're going to say, can you install them in parallel or something to that effect. And here's the ASHRAE chart right here. And here's where they point out R123 is a B1. And that's the end of the story.
Cool.
So sorry about the delay, but I really had